Hello engineers, how are you all? Hope you have a great day. Welcome back to Saturni's Tech. So today's tutorial we are going to learn how to calculate resistor color code, and this color code is very important as it's an A1 of electrical and electronic engineer supposed to learn how to use it. And then the topic outline we are going to discuss in this topic, I just categorize them into subtopics. The first subtopic is going to be uses of resistor color code, and the next one is going to be numbers of resistor color code, and then we are going to find list of resistor color code, and then we are going to have a working examples on resistor color code, and we are going to learn, or we are going to put what we have learned throughout this topic. And then the final one is going to be an assignment, and this assignment is just going to highlight you, or is going to test you how much you understand what we have learned or what we have discussed in this tutorial. So now let's discuss with the resistor color code, uses of resistor color code. And this use of resistor color code is just to highlight you or tell us or to identify the value of a particular resistor that we want to use. And this color code is let us know that the resistivity of that resistor that we are going to use or we are using in our circuit, because we cannot find the value of a resistor unless we can use 2 method. For that one, or the first one is going to be using multimeter, and the second one is going to be when it is identified from the company or from the manufacturer but the resistor is so value. But let's say we don't have both multimeter and then we don't have, or it is not identified in the carton or in the package of that resistor. So the best and the most recommended way is just to use our color code for which to find the value of that resistor we want to use. And then these are the numbers of the resistor color code. As I said, there are 13 numbers of resistor color code, and the reason why I said there are 13 is that, just follow me, I will tell you the reason why I said there are 13 in number. But if you check here, they are what? They are 12 in number. If you count from black to our silver, then it's going to give us 12. But when we include the non-value or the non-one, it's going to give us 13. And just follow me, I will tell you why, or the reasons why I say there are 13 in number. And now these are the resistor color code. As we can see here, we have the set of color would start from black to none, and we have first, second, third band, and we have decimal multiplier, and the panel column is tolerance. And then if you check closely, we can see that the black one at the first band represents 0, second band represents 0, third band represents 0, decimal band represents 1, and tolerance represents nothing. And then if you go to brown section, you can see that the first band represents 1, second band 1, third band 1, decimal multiplier represents 10, and tolerance it represents plus or minus 1%. And the meaning of this tolerance is that it just tells us that the resistor we are using, it can increase or reduce by 1% of that value of resistor. Let's say we are having 5,000 ohms resistor. So that 5,000 ohms resistor, it can be 5,001 or it can be 4,999, because it can reduce or increase by 1% of that resistor. This one is just an example I just stated. So now if you check closely to our last or to the right section, you can see that it represents 9 at the first band, and represents 9 at second band, and it represents 9 at the third band, and it represents 1 billion at the decimal multiplier. So, but it has nothing with the tolerance. It has nothing with the tolerance. So now, what is the reasons, or what is the essence of using this band? As you can see, we have first band, we have third band multiplier up to tolerance. So now the reason of using this band is that our resistor, it comes with different band. Some resistors come with 4 band, while some it comes with what? With more than 4. But most of the resistors we are using, they come with the 4 band. So now the resistor we are always using that comes with the 4 band, then we are going to use first and second band as they are. We are going to write them as they are, and then the third band is going to be our multiplier. It's going to be our multiplier, and the fourth band is going to be our tolerance. So now let's see. As Now, as I'm explaining, is that we have gold, we have silver, and this gold and silver, they represent our tolerance. Gold represent plus or minus 5%, and silver represent plus or minus 10%, and none represent plus or minus 20%. That's why I included this none as the word is part of our numbers, part of our colors, because whenever we are going to the value and it does not represent any color there, so it is telling us that the tolerance of it is plus or minus 20%. So now let's drop an example and see. As you can see here, we have a resistor that has a color that starts from brown, black, red, gold. So now the question here is that from where are we going to start writing down the color of this resistor? Are we going to start writing the numbers from the top or from the bottom? So now here is the answer is that we are always starting from the number or from the color that represents a number, not a tolerance. As we can see that gold, it represents a tolerance, and that tolerance is plus or minus 5%, while brown, it represents a particular number, and that number we are going to write it as it is. So now let's solve this example and see. As we can see here, as I said, brown, it represents 1, black represents 0, red represents 2, and gold represents plus or minus 5%. And as I said earlier, we are going to write the pause and scan band as they are. That's where I read brown is 1, as you can see, and black is 0, is just 1 and 0 as they are. 1 and 0, and that's 1 and 0, it gives us 10. It gives us 10. We're not going to say 1 plus 0. No, we are going to write it as they are. 1 and 0 just give us what? 10. And then we say times 10 to the power of 2. As I said earlier, that band, since our list, it has 4 bands. 1, 2, 3, 4. Then the third band is going to be our multiplier, and the final band or the fourth band is going to be our tolerance. So that's why we say 10 to the power of 2 is just 100, because 10 times 10 is going to give us 100. Then times plus or minus 5% at our tolerance. So we have 10 times 100 is going to give us 1000. Then times 5 plus or minus 5% is going to give us 1000 plus or minus 5%. And this 1000 is, it can be abbreviated as what? As K. And because K represents 1000, kilo represents 1000. So that's how we write 1 kilo ohms plus or minus 5%. Because our resistor, it can be increased or reduced by plus or minus 5%. So that's how we have plus or minus 5%, and ohms is just a unit of a resistor. So now let's solve another example and see. As we can see this in example 2, we are having a resistor that starts with a green, blue, red, gold. The question here, it goes like this: where are we starting from? Are we starting from green, or are we starting calculating this resistor from our gold? So the answer is we are going to start from a green, not the gold, because the gold represents tolerance, and we're always not starting from the tolerance side. We're always starting from a number or from a color that represents a number, not a tolerance. So now let's go and solve this one and see what's the value of it. As we can see here, the green one represents 5, blue represents 6, red represents 2, gold represents plus or minus 5%. As I said earlier, this is used to, it has how many bands? As we can see, it has 4 bands. If you count green, blue, red, gold, meaning that there are what? There are 4 color bands here. So now the first and second band, we are going to write them as they are. We are what? Going to write them as they are. So, and the third band is going to be used as our multiplier. We are going to write numbers of zeros, or let me say they are multipliers as, let's say, the power of to the power of that value it represents from the color. And then the top and the fourth one is going to be our tolerance. So now let's go and see. So now we say the first and second, we're going to write it as they are. We have 5 and 6 going to give us 56. And as I said earlier, we are not going to say 5 plus 6. No, we are just going to write our 5, then we write our 6, which is just going to give us 56. Then times our red is represent 2, and that 2 represents 10 to the power of 2, or 10 to the power of 2 times 10 times 10 is going to give us 100. Then we are going to have 100, then times plus or minus 5% as our tolerance. So now we have 56 times 100 is going to give us 5,600, then times plus or minus 5% is going to give us 5,600 plus or minus 5%. And then if we abbreviate it, we can divide this one by 1000, which is just going to give us 5.6 kilo ohms plus or minus 5%. So that's how we can find the value of a particular resistor or the resistivity of that resistor using the color code. So as I said earlier, we are going to have an assignment, and this assignment is going like this. What we are going to do is that we are going to find the value of this resistor. As you can see that the resistor, it has a 4 band, and then it has some set of colors. Then you are going to find the value of this resistor, and you are going to drop your answer in the comment section, and then I will try as much as possible to reply to each and every one of your replies or of your answer. I will tell you what's the answer. Did you find it correct or not? I will tell you. And then one question is that after you find the value of this resistor, then you should tell me from which side are we starting. Are we starting from the top or right, or from which side are we starting? Or are we going to start from the tolerance side, or from a color that represents a number? So that's the end of today's tutorial, and then don't forget to like, subscribe, and share this video with your ingenious friend. So thank you for being with me in this interesting tutorial.